So let's get started. Now, in network infrastructure, how we normally get things done, okay? This is what happens. And these are some real pictures and some fake pictures here. The first one is this one right here. Oh, look, we've got the, we've got the two Cisco routers and we got the switch down below it, and the wires start off like that. It's not a big deal. I mean, we'll get to cleaning this up in a little bit. We don't have time to do it right now because we're really busy and we just started out the company. Hey, can you go ahead and plug in a wireless module into that thing? And can you add some other stuff to that? And then it starts to look like this. And then a little bit later, we really don't have time for it because we're really busy right now. Like really, then it starts to look like this. And I'm sure you've seen these nightmares that are out there. The internet, you can type into any search engine and type in ugly network configuration, or there's even the opposite of that, which is the beautiful network configurations with all the wiring and everything. That's how it happens in our networks. But how should it happen? What's the engineering way to get network infrastructure in place? So you start off with a problem space. Now, you're not going to start with a green field. And you're going to inherit somebody else's garbage, but you still have to assess the communication needs or the gap at that moment in time. You're going to have to look at the bandwidth requirements on the local area network. That's kind of changed for the wide area network unless we have multiple offices, because today, I know in Austin, Texas right now, I can get 6 gigabits of service to my home. And so pretty much everybody in Austin can get at least a gigabit of service, even if you can't use Google these days. So bandwidth requirements to the internet for most offices or small office, home offices, is not that big a deal. It's the local area network bandwidth requirements that are really the big idea, especially in today's advent of AI, where we're going to need some heavy duty infrastructure to support the communication back and forth. Okay, then you set a solution space and you look at your transport technologies that we're using. It's probably going to be at certain points, there's going to be optical in there, there's going to be copper in there. And then when we get down to the end user's workstation, we could probably satisfy most with a standard wireless that's out there. There are going to be constraints. There's always going to be money constraints, and I understand that, and there are going to be time constraints. But look at things like the trust boundaries between one network and another, between one piece of the office and another, your VLAN infrastructures, those kinds of things. You're also going to have to determine latency limits across the wire for certain resources that you have. You're going to look at your bandwidth limitations that you're going to have. This happens a lot with wireless when we decide to have a meeting in the office and bring everybody into the office, and we've got a wireless access point or two in the conference room, and they usually handle everybody that's in there, but then all of a sudden, 60 people jam into that room and there's not enough network access in the world to go ahead and solve the problem. And the person that needs to be able to do the presentation in the room can't get access, those kinds of things. So look at your bandwidth limitations across the spectrum of all of your possible communication needs. And then there may be regulatory mandates within your organization. This happens in government and military or not usually, but not normally to corporate enterprises. We'll set up our characteristics, our design characteristics, select routing protocols that we're getting to the internet, define any kind of switching logic that we have, and specify interface configurations. These would be physical interfaces that we would have to slide into the back of modules. Think along the lines of the fiber modules as uplinks. That's usually where your specifications are going to change. And you've got to be consistent across your specifications of what module you're actually sliding inside of there. Then you're going to assess your design alternatives. You might get a vendor to bring this in. You might get a vendor to do your wiring for you in your physical plant. They may come in and take care of that. So look at what vendors have to offer you today. Figure out what protocol security you're going to need within your organization. And remember that if you're going to implement VPNs, that's going to put a particular load on those VPN concentrators. Those VPN concentrators have a certain amount of CPU. We'll call them internal bandwidth for themselves. Look at the hardware capabilities. This is especially true for security and for core and distribution networks that you're working with. Then you're going to implement the process, and that usually is configuring the routers, well, after the wiring's done. Configuring the routers, installing the switches, deploying firewalls at a bare minimum. We don't talk a lot about security in this section, but it's still important to us. And then hardening those devices that are out there. So not, your routers and switches, they have configurations on them that need to be tuned to your environment and, tightened down. Then we're going to assemble all of the system elements. This is connecting the network segments, integrating authentication servers, and link management systems if we have those in place. We then have to go back to the original statement of what people needed, what the business requirement was, and demonstrate that by validating the mission requirements are achieved under different loads. This will require you sometimes to bring in testing equipment to make this work that you don't necessarily have on site. Then you're going to perform maintenance against all of this. You're going to monitor the key performance indicators across your entire network, update firmware versions, and replace failed hardware. Now, your network, the way your world is set up, is somewhere in between the awful wiring diagram that I showed you at the very beginning and this perfectly engineered process. I don't know what that looks like for you, but if you come along with me, I'll show you all of the components that can help you get there and make sure that you do that securely. Now, this is not network security at this point. This is network infrastructure, and then it has its own security elements within it. We're adding in an AI element to everything we do these days. And I wanted to break this down for us today into what kind of agentic network tools that we can have and how to build prompts for a lot of troubleshooting or problems that we're having when we're doing design. So on the agentic tools, I didn't dig deep into these tools. I talked about the vendors here. Like for orchestration platform, AWS has something called Bedrock Agent Core that will help you on the AWS platform. It won't help you at home, but it'll help you in the AWS platform. Framework ecosystem is probably going to be LangGraph or Crew AI. They've got some really excellent tools. I read a little bit about them. I don't use them myself. For infrastructure specialist, you've got Juniper, if you have Juniper networks, and they have Marvis. And then there's Kentik AI Advisor that goes across a lot of different devices that are out there. For operational assistance, look at Cisco's DNA Center. I think that that's a worthwhile tool, but remember the Cisco stuff's a little pricey out there. So that takes care of the high-level networking tools. Let's go into AI troubleshooting prompts. How do we build those troubleshooting prompts that are going to work well for us with whatever AI assistant you're using today? We'll start off with breaking this down into the 6 different components. You set an expert role, establish a technical voice, structure the core task, provide context, apply logic, and then optimize the model for performance in your particular case. For defining expert roles, I think if you're doing networking, I would say Cisco network engineer. I tried to key in one time Cisco CCIE, and it didn't understand that that was a network engineer. So be specific about it. Establish a technical voice. So tell it to use a formal tone, omit marketing jargon. Structure your core tasks that you're going to perform. And this breaks down into designing system layouts or troubleshooting. For the design system layouts, you'll say create a topology diagram or specify hardware requirements. Now, this is the one that is problematic. A lot of the network diagrams that I am seeing come out of AI agents are used by the drawing mechanism that they have or the creating, art and fun things, and they're not really technically adept. So be worried about the topology diagrams that you have there. Make sure that you test everything. I would go to regular topology tools out there. I'm waiting for the market to attach an AI tool to a network diagramming tool. I would really like to see that happen. If you can't use that, there are a couple of other vendors out there that will actually interrogate your current network and bring back and build network diagrams for you without any AI involved. And then you also may want to specify your hardware requirements, where you are, what you want to go to, or what your throughput needs to be. If you're doing this if you're structuring your core task along the troubleshooting lines, you may say analyze the traceroute results. That means you've got to give it the traceroute results. Interpret the syslog data. That means you've got to be able to pick it up and drop it in there. And diagnose packet loss. You can't just say diagnose packet loss. You've got to give it some data here, some throughput statistics. This is where the rich context comes in. So you can insert your raw data like device logs, CLI outputs, and telemetry metrics. You could also detail your constraints at this point. You may have budget limits and a list of hardware that you already have and what other piece of equipment will I need to go ahead and complete what's going on here. Explaining the user need, I think, is kind of critical for us in that rich context, like identify the critical applications or map the traffic flows for us. Now, there are a lot of other tools that you're going to map into this and you're going to work with this. So realize that it's not going to be able to do it on its own. It can't read your mind and it doesn't know what your network looks like unless it's one of those other tools that we talked about. So then you're going to apply a logic framework to what you're trying to achieve from it. Like, give me step-by-step reasoning. Use a few shot learning where you go through it a couple of times and say, okay, I got this, I got this, I got this, and let it return values to you. You could also request specific outputs, things like JSON files, markdown tables, or drafting a technical report. I would be really careful about these at first. Remember, it's not going to get this right the first try, so you're going to have to review it and make sure that it's true, but it's a lot easier than doing all the writing that goes along with it. Lastly, when you're in a particular model, you're going to optimize for performance within that model itself. And you start off by minimizing hallucinations. How do we do that? Well, we set a low temperature, or we can even say to it, reduce the hallucinations, make sure that you give me accurate details here. You can do a refinement of iterative prompts by clarifying ambiguous terms that you may have come up with, ask follow-up questions, and validate final suggestions. Lastly, you can improve prompt efficiency by defining maximum lengths. Well, one of my favorite tools that I've been using lately is Notebook LM. And for my network, I go out and I find the manuals and the displays, all of the different manuals and all of the different technical specifications of all of my different devices, and I load them into Google's Notebook LM. So that's my starting basis of where all my tools are inside. So I hope you enjoyed that, and I hope you'll join me for the entire presentation.